Welcome to part 2 of the Unit 9 notes, part 1. Here we're just going to do some examples with the sum and difference and the double angle formulas. So the first thing you'll notice is that it gives you an angle for the sine, and it tells you the quadrant, and this is quadrant number 3 because it's between pi and 3 pi over 2. So the first one is the sine of 2 theta. Now, in order to do the sine of 2 theta, remember we do need to know the cosine of theta because it's 2 sine theta cosine theta. So because it says the sine is equal to -4/5, that means that y is equal to -4 and r is equal to 5. Which means by Pythagorean theorem, x would be 3, and it's negative since it's in the third quadrant. Which means the cosine of theta would be -3/5 because it's x over r. So you get 2 times -4/5 times -3/5, which is 24 over 25. Now, for a cosine 2 theta, you have 3 ways that you could do this. I'm going to use the one that says cosine squared minus sine squared. So it's going to be -3/5 squared minus -4/5 squared. So it's going to be 9/25 minus 16/25, which is -7/25. Part C, tangent 2 theta, it's going to be, there's 2 things that you could do. Number 1, you could use the formula, which is 2 tangent theta over 1 minus tangent squared. Or you could just take the sine of 2 theta divided by the cosine of 2 theta. But let's say you didn't have sine theta, cosine theta, you just had to find the tangent, or sine of 2 theta and cosine of 2 theta. The tangent here, remember, of theta would be y over x, so it'd be 4/3. So if I put it in the formula here, I have 2 times 4/3 over 1 minus 4/3 squared. So you have 8/3 over 16/9, 1 minus 16/9, so it's going to be -7/9. So you go 8/3 times 9 over -7. So you get -24 over 7. So now the half angle formulas. Well, for part D, the quadrant that the half angle is in, well, if the full angle is in the third quadrant and you divide that by 2, you know, pi over 2 to 3 pi over 4, that is in quadrant number 2. So that's helpful to know if it's positive or negative. So remember, the sine of the half angle is equal to the square root of 1 minus cosine theta over 2, and remember, because of the fact it's in quadrant 2, it's going to be positive. So 1 minus -3/5 over 2. So it's going to be the square root of 5 plus 3 is 8/5 over 2. So that's the square root of 4/5. And the square root of 4 over the square root of 5 gives you 2 over rad 5, which is equal to 2 rad 5 over 5. So now we're going to do the cosine of the half angle. Which is the square root of 1 plus cosine theta over 2, and now it's going to be negative because we're in the second quadrant. So it's going to be negative rad 1 plus negative 3/5 over 2. So it's going to be 2/5 over 2, which is just going to be 1/5. So it's going to be negative 1 over rad 5, which rationalizes to negative rad 5 over 5. And for part G, the tangent, well, remember the tangent of the half angle is equal to sine theta over 1 plus cosine theta. Now you could also do the sine of the half angle over the cosine of the half angle, but let's say you didn't know those two values, so you could use the formula. The sine of theta is negative 4/5 over 1 plus negative 3/5. So it's negative 4/5 over 2/5, which is equal to negative 2. All right. Number 2, so now we're doing the sum and difference formula. So now we have two angles. We have alpha, and we know alpha is in quadrant number 3. And we know this because the sine, so we know that y is negative 4. We know r is 7. So then when we do the Pythagorean theorem, we get that x is negative rad 33. And then we have beta, which is in quadrant number 4. And we know that the cosine, so we have x is 2, r is 3. So we know y is negative rad 5 when we do the Pythagorean theorem. So for part A, we're doing sine of alpha minus beta. So remember that's sine alpha cosine beta minus cosine alpha sine beta. So sine alpha, remember, is negative 4/7. Cosine beta is positive 2/3. Cosine alpha is negative rad 33 over 7. And sine beta is negative rad 5 over 3. So then it's just do the math. So it's negative 8/21 minus the square root of 165 over 21. And so it's negative 8 minus rad 165 all over 21. And if you type that in your calculator, that is, we'll figure out if it's positive or negative. And it turns out to be negative. So let's do part B, cosine alpha minus beta. So it's going to be cosine alpha cosine beta plus sine alpha sine beta. So cosine alpha, remember, is negative rad 33 over 7. Cosine beta is positive 2/3. Plus sine alpha is negative 4/7. Sine beta is negative rad 5 over 3. So we have negative 2 rad 33 over 21 plus 4 rad 5 over 21. So either way you write it, 4 rad 5 minus 2 rad 33 over 21. And that is also a negative value if you put that in your calculator. The reason why that's important is because when you get to part C, if both sine alpha minus beta and cosine minus beta are negative, that means it's in quadrant 3. So to find part D, you're finding alpha minus beta prime. So to find alpha minus beta prime, the reference angle, you're going to take the sine inverse of negative 8 minus rad 165 over 21. So on your calculator, make sure it's in radian mode because the quadrant boundaries are in radians. So you go second sine negative 8 minus, actually let me do this way. Let me put the parentheses here. So it's negative 8 minus rad 165 divided by 21, and then you hit enter, and notice you get 1.449. Remember, the reference angle can't negative, so theta prime is equal to 1.449. And since alpha minus beta is in the third quadrant, to find alpha minus beta, you would go pi plus 1.449, and that's equal to, when you do that, it would be 4.591 when you type it in your calculator. And so that's alpha minus beta. All right, next, for number 3, it tells us the cosecant of alpha, where the tangent of alpha is negative. So if the cosecant is positive, that means the sine is positive, which means, and the tangent's negative, which is in the second quadrant. So that means for alpha, that means r is 5, y is 3. So that means x is negative 4. And for beta, if the tangent is 7/2 and the cosecant is negative, that means that's in the third quadrant. Alpha is in 2, beta is in 3. So that means that the y is negative 7, the x is negative 2, and the r is the square root of 53. So if we do the first one, sine of alpha plus beta, remember that's sine alpha cosine beta plus cosine alpha sine beta. Sine alpha is going to be 3/5. Cosine beta is going to be negative 2 over rad 53. Plus cosine alpha is negative 4/5. And sine beta is negative 7 over rad 53. So for this one, it's negative 6 over 5 rad 53 plus 28 over 5 rad 53, which gives us 22 over 5 rad 53, which when you rationalize gives you, if you multiply by rad 53, it gives you 22 rad 53 over 265. So that's sine alpha plus beta. Now we can do the same thing for the cosine. I'll just scroll over here. For part B, cosine of alpha plus beta. That's cosine alpha, cosine beta, minus sine alpha, sine beta. So substituting in, so cosine alpha is going to give us -4/5. Cosine beta is going to give us -2 over rad 53 minus sine alpha is going to give us +3/5. Sine beta -7 over rad 53. So you multiply and you get 8 times 5 over 5 times rad 53 minus a minus, so it's plus 21 over 5 rad 53. So it gives you 29 over 5 rad 53. When you multiply to rationalize, you get 29 rad 53 over 265. That's cosine alpha plus beta. So now the next one says the quadrant that it's in. Well, they're both positive. So that means for part C, it's in quadrant 1. Part D, you want to find the reference angle of alpha plus beta. And the reference angle is, we'll take the sine inverse of 22 rad 53 over 265. And when you type that in your calculator, you get 0.649, or in degrees, depending upon how you do it, because it doesn't specify, so you could do it either way. It's 37.185 degrees. Now for part E, it wants to know what alpha plus beta is. And remember, if it's in the first quadrant, so you took a second quadrant angle and you added it to the third quadrant angle and you wound up in the first quadrant, that means you made one full rotation. So you can take 2 pi plus 0.649. So you get, in radians, you get 6.932. Or you could take 360 degrees and add it to 37.185 degrees. And you can get 397.185 degrees. All right, the last ones are just different kind of applications. You can use angles in the unit circle to find the exact value for these trig functions. Exact value means a fraction, no decimals. So sine 15, you could take sine 45 minus 30. So that'd be sine 45 cosine 30 minus cosine 45 sine 30. So that'd be rad 2 over 2 times rad 3 over 2 minus rad 2 over 2 times 1/2. So it's rad 6 over 4 minus rad 2 over 4. And it's rad 6 minus rad 2 over 4. So for part B, the two angles in radians that add or subtract to 7 pi over 12, well, you could do pi over 3 plus pi over 4. So for cosine, so it's cosine pi over 3, cosine pi over 4, minus sine pi over 3, sine pi over 4. So you get the cosine pi over 3 is 1/2 times rad 2 over 2 minus square root of 3 over 2 times rad 2 over 2. So you get the square root of 2 minus the square root of 6 over 4. Cosine 75, you could do cosine 45 plus 30. So you go cosine 45, cosine 30, minus sine 45, sine 30. So you get rad 2 over 2 times rad 3 over 2 minus rad 2 over 2 times 1/2. Square root of 6 over square root of over 4 minus rad 2 over 4. And there you go. Sine 7 pi over 12. Well, remember 7 pi over 12 is pi over 3 plus pi over 4. Minus cosine pi over 3. So sine pi over 3 is rad 3 over 2, sorry. Cosine pi over 4 is rad 2 over 2 minus 1/2 times rad 2 over 2. So it's rad 6 minus rad 2 over 4. Actually, sorry, it's plus, because this will be a plus. Because remember, sine, it's the same sign. It's cosine that is opposite. All right. The last page is just all the identities, so keep that reference that you can use on a given problem. And yes, I hope you enjoy this. And if you have any questions, feel free to email me, or I will see you in class. Have a good evening.